Okie dokie. So let's go over the exam first. All the grades were up. For on the whole, the grades were pretty good. I think there were a lot of A's and B's. But then there were some really low grades, some single digits, some less than 30. So if you are one of those people, you really want to ask yourself why, what was the reason? Did you not prepare for the exam? Whatever. The most disappointing things were questions that I told you would definitely be on the exam that were still missed or even left blank. Yeah, so I don't know what to do with that at the end of the day. So in any case, let's go ahead and look at the exam. All right, so first question, convert 1257 from octal to hexadecimal. All right, well, remember that we do have the shortcut where all octal numbers are 3 bits. So we can go from octal to binary and then binary to hexadecimal. So 1, 2, 5, 7. And just so everybody's aware, for those of you who are still coming online and getting put in the waiting room, if you log into Zoom with the SSO button and log in with your Concordia credentials, you won't get put in waiting rooms in your classes. They'll let you right in. All right, so 1, 2, 5, 7. We first need the octal for 1, that's 0, 0, 1. The octal for 2 is 0, 1, 0. The octal for, or the binary for those, the binary for 5 is 1, 1. Let's see if it's a 1, 0, 1. And then octal for 7 is a 1, 1, 1. All right, so that means that the binary for this is 0, 0, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1. All right, so we can take that now and break it into chunks of 4. And this gives us a 2. This is a 1's place, a 2's, 4's, and 8. So this is a 10, which is an A. And then this is a 15, which is an F. So if you want to see that underneath it, this is a 2. This is a 10. This is a 15, which then becomes a 2, an A, and an F. So this is the hexadecimal version of the octal number 1257. The other thing you could have done is you could have done the thing where you convert octal to decimal. So you would say that the 7 is in the 1's place, the 5 is in the 8's place, the 2 is in the 64's place, the 1 is in the 256 place. Add them all up, giving you your decimal number, and then divide by 16 over and over and over again, recording the remainder. And in the end, you would have ended up with a 2AF. All right, questions on that one? All right, number 2, does the double equal sign allow you to compare the contents of strings? No. Double equal sign is the primitive comparison operator. It would compare the memory addresses of the strings when used with strings. To compare strings, you would use the dot equals method, something along those lines. Okay, talked about that quite a bit. Double equal sign is for primitive types. So if you compare 2 strings with each other, you are comparing the memory addresses if you use the double equal sign. If you actually want to compare the contents of those strings, you have to use one of the strings instance methods, which does compare the contents of the string. All right, questions about that one? All right, next one. Write a function in Java named count chars that takes a string and a char as a parameter, as parameters, and returns the number of times the char parameter appears in the string. All right, so we are returning the number of times, so we're going to return an int. The name of this function is going to be called count chars. It's going to take in a string as a parameter, as well as a char that we're searching for. Let me see if I can make this a little bit bigger. I don't know if that helped or not, but let's just go with it. All right. So now what we want to do is we want to have a variable to count. So maybe we say int count, start this guy off at 0. We want to loop through every element of our string. So for I is 0, I is less than s dot length, the number of elements in our string, I plus plus. All right, then we want to ask the question, if the current element we're looking at. Now remember, in Java, to access the current character in a string, we use the char at method. So we're going to say if s dot char at I, if that character is equivalent to the character that was passed in, then we want to increment our count. Okay, if it's not equivalent, we just keep moving on through the string. When all is said and done, we will return the value of count. Again, we are returning the number of elements, the number of times that the character C appears in S. So we're returning an integer, not printing an integer, we're returning an integer. All right, the way we access an element in a string is s.char at I, not s bucket I like that. A lot of people did that. That's our array syntax in Java. But, you know, in any case, that's the scoop with that. All right, questions about that one? Okay. Everything's still coming through okay, audio wise and visual and all that stuff. I'm not hearing anybody and I'm not seeing anything in chat. All right, we got it kind of. So we're following okay-ish. I'm also recording, so you'll have the whole recording, and that's local. So all right, so how do you distinguish, question 4, how do you distinguish between a class method and an instance method when looking at the definition of a method in Java? Okay, again, the focus here is on the definition of that method when it was actually written. Okay, a class method will have the keyword static in front of it when being defined. An instance method will not have the keyword static in front of it. All right, class method will have the keyword static in front of it. Instance method will not have static in front of it. All right, so this is making sure you understand the difference between the definition of a method and calling methods. So in this question is asking, if you're looking at somebody defining a method, you're looking at the actual implementation of the method. How can you tell if it's a class method or an instance method? You're looking for the keyword static. If static is there, it's a class method. Static is not there, it's an instance method. All right, questions on that one? That one was missed too often, especially for the number of times we harped on it. All right. Next question is on the other side. How do you call a class method in Java? How do you call an instance method in Java? Give an example of each. So you call a class method using the name of the class in which the method was defined. You call an instance method using an instance of the class in which the method was defined. So if you want to give an example of each of these, character dot to uppercase, if I pass that in A, this will convert lowercase a to uppercase A using the character classes to uppercase class method. String S is equal to hello, S dot to uppercase will convert hello to hello using the string classes to uppercase instance method. Okay. So that is the answer for that one with some examples. Some people didn't give examples. And examples are important in here because sometimes when you're describing it, you're not necessarily using the precise word. So in here, I'm saying a class method, you call a class method using the name of the class in which the method was defined. Some of you may have shown me that you understood what you were talking about through your example, but you might have said something like you call a class method using the name of the instance in which the method was defined or something like that. You swap around words so the example drives home the point of whether or not you understood it. So that's why I asked for the example. All right, questions on that one? All right, next one. Difference between public, private, and protected keywords. Give an example of when you might use each. So public means we really talked about it in terms of fields, means the field or let's say other class members can be accessed from anywhere in the package, which from our perspective is the same directory. Protected, private. So protected means the field or other class members can be accessed from, actually, I'm going to switch these around. Let's go private and then protected. So private means the field or class member can be accessed only from within the class the member was defined. Protected means the field, I'm going to just steal this guy. This could be accessed from within the class the member was defined or children of that class. So this, we're going to say this supports inheritance. All right, example when we would use each. Public, when we want a method or field to be accessible from wherever we created an instance of our class. Private, when a method or field only needs to be accessed from within the class as part of the implementation. Protected, it's a similar to private, but the implementation is done at the child level, and we need access to variables that might otherwise be private. But we definitely do not want, say, outsiders to have access. All right, something along those lines, understanding kind of the decision making that goes into the public, private, protected. All right, questions on that one? Okay. What does the abstract keyword do? Okay, so abstract, this one was also missed way more than it should have been. So abstract makes it so an instance of a class cannot be made. It is usable. Well, it is call it best used when we create a base class whose purpose is solely to support inheritance. Like the inhabitant, a lot of you reference this, like the inhabitant class we created in our dungeon. We would never create plain inhabitants. Instead, we create players and monsters. So we made inhabitant abstract. Okay, questions on that one? Question 8, what do threads allow us to accomplish? Give an example on when a thread would be helpful. Okay, so threads allow us to have code that executes in the background, while other code either blocks or progresses down its own path. This is useful when we need more than one thing to happen at once, or avoid a blocking situation where the program stalls due to waiting for something like user input. We use this in our dungeon to allow monsters to roam around while the player was deciding what they wanted to do next. All right, questions on that one? All right, next one, create a Java class named book that keeps track of a book's name, author, and number of pages. So we're keeping track of 3 pieces of information. Create appropriate fields with proper security settings, an appropriate constructor, and getter methods for the fields. All right, so we're going to have a class called book. All right, we're going to have 3 fields. So we're going to have a private. We're going to keep track of the name, the author, and the number of pages. So 2 strings and an int. So name, private string author, private int num pages, something like that. All right, now we need a constructor for this guy. So we'll say public book. Okay, book constructors don't have return types, but they have the same name as the class. And we're going to take in the 3 parameters. So we're going to take in a string name, a string author, and an int num pages. We'll say this dot name is equal to name. This dot author is equal to author. This dot num pages is equal to num pages. All right, so there's our constructor for that takes in the 3 parameters and initializes our private fields. Now, since those fields are private and our rule of thumb is make everything private initially and then loosen the reins if we have to, we're going to give ourselves 3 getters for those private fields. So we're going to have a public string get name. This guy will return this dot name. We're going to have a public string get author. This will return this dot author. And we'll have a public int get num pages. So return this dot num pages. Okay, so something along those lines for our book class. Right, you didn't need to give me main, you didn't need to create instances of it. We created the blueprint. We created the class for book that holds 3 pieces of information, a name, an author, and a number of pages. We created the appropriate constructor for taking in those 3 pieces of information. And then we created 3 getters, which gives us read-only access to these private fields. Questions on that one? Okay, last question, question 10. Write a Java method named array2string that takes an array of integers as a parameter and returns a string with the contents of that array. With each element separated by a comma. For example, if the input was the array 1, 2, 3, 4, 5, your output should be the string 1, 2, 3, 4, 5. Notice there is not a final comma on that that guy. Okay. If you happen to put a comma after everything, it wasn't the end of the world. It probably took off 1 point or something like that, if the rest of your logic was fine. All right, so see, we are returning, right? This returns a string, not prints a string, returns a string. So we're going to have a return type string. We're going to call this guy array2string. It's going to take in an integer array as a parameter. All right, so maybe we create a starting point string called answer. All right, now we have a couple of different ways we can go about it. We can say we're going to spin through every bucket of the array except the last one, and then tack the last number on at the end with the comma. So I'm going to go ahead and do it that way. So I'm going to say for int I is equal to 0, I is less than AR dot length. It's not a method, it's a field of the array class. If you put open and close parentheses on it, I didn't take off points, but for arrays, their length is AR dot length, just as a field. All right, but we're going to say length -1. We're going to say I++ because we actually don't want to go to the very last guy, because I'm going to just tack the last guy on at the end after my final comma. Now, technically, this guy could be a little bit of a problem if we have a array that only has one element in it. But you know, this is fine. Otherwise, you could have an if statement in the middle of it that just says, if I'm dealing with the last guy, don't put in the comma, something like that. I'll throw in the catch-all at the beginning of this one to make it fully correct. So let's just write this part of it first. All right, so each time through, we'll say answer is equal to answer concatenated with, we want to go ahead and get our array at bucket I. Now, we are allowed to do this. In Java, you can concatenate an integer onto a string. You don't have to get two string types together or anything like that. So I didn't have to get like the string value of that integer. All right. And then I'm going to go ahead and just tack on a comma after that guy. So whatever answer currently is, concatenated with the next integer, concatenated with a comma, spin through. So we'll build up in our example here, 1, 2, 3, 4, comma, and then we end. And then finally, we're going to say answer is equal to answer concatenated with AR at bucket AR dot length -1, the last legal element in that array. And then we'll return the answer. All right. So as it stands right now, this guy works for everything that is at least 2 elements in the array. If we just have a single element, we could just throw a catch-all here at the very beginning and just say something like, and if you just wrote what I wrote there, it was fine. You got full credit. But you could throw a catch-all here and say if AR dot length is equal to 1, we would just return the empty string concatenated with AR at bucket 0. If you really wanted to be thorough, you could also throw a, you know, if they set me a empty array for some reason, we can just return the empty string, something like that. So 2 special cases. If they gave me an empty array, I'm just going to return the empty string. If they gave me an array with 1 element in it, I'm going to just return that 1 element. I don't have any commas. Otherwise, I'll go ahead and build my magical comma thingy. All right. Keeping in mind that the return keyword makes a method immediately end. All right. If you wrote what I have down here or something like it, but you didn't handle the special cases, that's fine. I still gave you full credit. Many of you inside your for loop, you just threw in an if statement basically saying, if this is my last time through the loop, go ahead and do something. In that case, you would have actually accounted for these 2 special cases inside of your loop. So for those folks, it would have looked like this. If I is equivalent to AR dot length -1, then what we can do is we can actually just return the value here, but I'm going to just stick with our building up the string. Since Java is going to complain if we don't return the value eventually. So we'll say answer is equal to answer concatenated with AR at bucket I. Otherwise, we want to do the concatenation with the comma thingy. Something like that. So either one of those is fine. I suppose just from a minimizing special cases perspective, this one's probably better, but whatever is okay. All right, questions about that? Okay, so that was the exam. As I said, the grades were pretty good overall. I think most of you, something like, I don't know, 70% of the class got A's and B's. I think the average score on the exam was like a 79.8 or something like that. So if you're in that zone, you're right where you should be. If you did substantially worse than that, I would ask yourself, why did you perform poorly? Did you not study? Have you not been keeping up on the assignments, whatever it is? You know, because things are only going to get more difficult from this point forward. Several of you who earned, like, I think the low grade on the exam was like an 8. I mean, you really need to consider whether this is the right direction for you. This is your second semester coding class, and if that's where you're sitting right now and you don't have a real explanation of something going on in your life, or just lack of preparation or whatever for it, you know, you might want to talk to me about whether or not this is going to be your cup of tea. Okay, so in any case, that's the exam. Go ahead and take a look at your exam scores, and I have feedback on there. So if you missed points, I tell you why you missed the points and that kind of stuff. So feel free to reach out and, you know, ask me questions if you have questions. Otherwise, remember that my policy is if you do better on the final exam than you did on the midterm, I will replace whatever you got on the midterm exam with what you get on the final exam, so you can undo a potentially bad grade on this exam. But I would say, like, for those of you who got like single digits or, you know, less than a 30% on the exam, you might truly ask yourself whether or not you're likely going to get a substantially better score on the final exam. But, you know, that's up to you, and I'm happy to sit down and talk to you about it if you want to, you know, want to get my honest opinion on it. Okay, so let's go back to our Unity project in our final 10 minutes here or so, 15 minutes, I guess. So hopefully the internet's holding out okay. Today is probably going to be the worst of the 3 days. We're in the middle of the ocean right now, literally in the middle of the ocean. The other 2 days we're at islands. So, so we're in the middle of the ocean traveling at like 25 knots currently. But I will get the video uploaded right after class. But in any case, let's go back over to Unity here. All right, and so let's remind ourselves where we left off. Let's see, what does the chat say? Yeah, so I'm hearing that my audio breaks up quite a bit. So in any case, you know, I am recording it, and the it's a local recording, so it'll have, everything will be clear on the recording if you want to go back and listen to the audio better for the explanation of the different questions. Let's see if it's still breaking up a bunch. Well, let me just spend a few minutes kind of reviewing our Unity thing, even if it's still breaking up. We'll at least get it on the recording, and you can watch the end of the recording to remind yourself where we're at, following the break. And like I said, the next 2 classes, I'm by a place where if the SpaceX Starlink isn't working well, I can create a hotspot on my cell phone, so we should be good the other 2 days. So at least for the recording, let me go ahead and go through, kind of catch us up on our project where we're at, and I won't start anything new on it, and then we'll just call it a day today. And then you can review your exam and stuff and ask questions between now and next class, and I'll be able to reply. All right, so if I go ahead and hit play on our game here, okay, remember we set up a thing where we can kind of drive our ball around. And I mentioned last time that I might need to put up some walls so that I don't drive it right off. But we want to remind ourselves a little bit about how this is currently working. All right, so we have our player. That's our kind of our main dude right now. And remember, all game objects have transforms. So that's a position in the XYZ coordinate field. We have our collider on this that allows it to, that allows physics to take place on our player. And so does the rigid body that allows it to fall down to the floor. We haven't actually used our collider yet. We're going to be using the collider when we start collecting our, whatever they have us collecting, stars or little blobs or something like that for score. Okay. We're using the built-in player input system, which was kind of stupid, but I guess whatever. And it sends some messages, and I'll review that in the code here in a minute. Okay, but this is a component we added to our player for player input. And we have this controller script. So we attached some C# code to our player. And this is associated with a script called player controller, which is this guy right here that we've stored inside of our scripts folder. Go ahead and double click on this guy. So here's our player controller. Okay, now if you remember from last time, and we'll kind of connect this to where we were just in the for going over the exam a few minutes ago. Here's a class just like any other class called player controller. Now this guy happens to be a mono behavior. So this is like extends mono behavior in Java. So the way we do inheritance is through this colon. Now notice that 2 of my fields are private, which means they are only accessible inside of this class. This last one here is public. All right, this public one, not only is it accessible outside this class, we did talk about in the slide something called MVC. Let me bring that back up here. I think we talked about MVC. I at least talked about it out loud. We just added here to the slides. So you have something called MVC. This is the model view controller. All right. Before I even throw that in there, I'm going to add something here called a design pattern. So I'm introducing a little something new. And even if my audio is breaking up, hopefully you can at least read what I'm writing here. So a design pattern is a proposed good solution. I'm going to put good in quotes to a quote common problem. Now this is very open-ended in that good is kind of in the eye of the beholder, and what's a common problem to me might be not a common problem to somebody else. If you work for Lockheed Martin, a common problem might be missile tracking, that type of thing. But in general, design patterns are, it's a kind of a joke in academics that a design pattern is an easy way to get published, because you can kind of invent a way of doing something, and in the end saying it's not a very good solution or something like that. An example is, what is the best way to make a peanut butter and jelly? All right, so if I polled the whole class, we would probably get 2 or 3 different approaches, let's say, to making a peanut butter and jelly, in terms of, do you toast the toast? Do you not toast the toast? Do you put the peanut butter on first? Do you put the jelly on first? How do you actually make it work? Do you spread it on? I always just put globs on and just squeeze the bread together and get it mushed all around. It seems easier. But each one of those would be a design pattern, an approach to how to make a peanut butter and jelly. And then the user can decide whether or not that's a good solution or not, but it's still a solution. All right, so this is the idea of a generic design pattern. It's a proposed solution to a problem. MVC is a design pattern called Model View Controller. Model View Controller says it is a good idea to keep your logic separate from your interface separate from your data. So model is the data, view is the interface, controller is the logic. So in our example that we're looking at right now inside of Unity, we actually don't have a model right now. We're not using like a database or something. So forget about model in our current example, but we do have a view and we do have a controller. So in Unity, the view is the visual part of our game. In Unity, the controller is the scripts we attach to game objects. So in our example we're looking at right here, this part right here that I'm looking at, this is our view. All right, we've created this scenario of design. Let's put the player at the center. I can zoom out. All right, so we've created this scenario for our design, and this is everything that's visual. Now, we wanted our player to do some stuff. So we created a script, we attached that script to the player, and then this is the controller for that game object. So we're kind of seeing MVC in action. Now I'm going to add a piece to our MVC definition though. Back in here, it's a good idea to keep your logic separate from your interface, separate from your data, and then provide some mechanism to make them talk when needed. I'm going to put a note here. Design patterns are not implementations. They are ideas / approaches. Okay. Now what that means is basically if you're doing if you're an Android developer and you're using Android Studio, doing some stuff in there, they have their own approach to MVC. MVC is still the same thing we're talking about here, but their approach is different than Unity's approach to MVC. Okay, Unity's approach to MVC is as follows. If I want something from my code to be available in my view, to my interface here, I make it public. By making this guy public, yes, I can access it inside of my code here, just like I can all the private ones, because private means it's accessible anywhere inside the class. Public means it's accessible anywhere. Okay, but by making this public here, Unity picks up on that variable. Okay, the variable's name is speed. I started it off at a 10. We go back into Unity here. I click on player and I go down to that script. Notice I have a speed variable here and I had adjusted it to 20, but The default was 10 for it. So effectively what happened is I gave myself access to that variable from the interface, and I can change its value in here if I want to. So I gave it a default value of 10, but if I want it to be faster, if I want it to be 50, this guy's going to move too quick for me now, but it was too fast for me before. Whoa, gone. All right. So in any case, that is an example of how MVC works in Unity. Okay. So let's go back to our script here and keep reviewing what we are doing here. All right. Remember, start. This is like our constructor. Okay. So start is gets called one time when this controller when the script first launches. And what am I doing? I'm extracting the rigid body from the component. I'm extracting the rigid body component from the owner of this script, which is my player game object. So this will get me the player's rigid body. Get the player's rigid body component. All right. Then I'm creating this input vector, and I'm starting it off at 0, 0 because I'm going to use it later on for my input stuff. All right. It's a XY coordinate thing. Although I think we're doing it as an XZ coordinate thing. All right. So now, before we look at on move here, let's go to fixed update. Remember, fixed update, this guy happens 60 times per second, as opposed to update, which happens every single frame. All right. And what am I doing on fixed update? 60 times per second, I'm going to add a physical force to that rigid body. What physical force am I going to add? I'm going to add a new vector 3 that is going to be whatever my input vector is on X, 0 on Y, and then whatever my input vector is on Y as my Z coordinate. So I'm using X and Y, but I'm using them as X and Z because Y is the up and down, and we're not changing the height of our player. Our player is moving left and right and then in and out, which is that Z. All right. And I'm multiplying that by the speed, and that allows him to move at a different force. Now, remember, this is happening 60 times per second, and it's using this input vector to determine that direction. That input vector is getting set right here. On move gets called automatically by the Unity input system. So we're going to update the current input vector every time it is called. So whenever we hit a button, this guy gets called, input vector gets updated, and then 60 times per second, we are applying that updated direction to our force. All right, I think that brings us up to date with our current code. I'll stop sharing here, and maybe that'll actually clear up the audio a little bit. I will get the video uploaded here right away, and I'll post in Slack as soon as it's updated if you want to go back and hear the audio a little bit better. But hopefully you're able to pick up on enough of it to kind of keep up. Maybe give me some feedback in chat on just how bad it was. So I know whether or not to even try the satellite on Wednesday and Friday, or just to use my cell phone hotspot. Either one will be available. All right. Questions, comments, concerns, bribes. All right. I will see everybody on Wednesday. So for people that are still on, was it completely unintelligible or did it have moments of clarity?